Hello everyone. In the last session, we have seen about the volumetric strain for uniaxial stress system, biaxial stress system and triaxial stress system. Now, depending upon that, next we are going to learn about elastic constants. There are various elastic constants used in the mechanics of structure. Now, we have already learned about the modulus of elasticity and something about the modulus of rigidity. Now what is meant by modulus of rigidity? We already know. What is the modulus of elasticity? It is also known as the Young's modulus, and it is the ratio of stress to the strain. We can say linear stress or linear strain. Now it is generated by sigma and E. We already know about it, modulus of elasticity, and it is derived by the Hooke's law, because we already know within the elastic's limit the stress is directly proportional to the strain, and that constant we have considered as Young's modulus, sigma upon E. Now here the next term is, that is the next elastic constant is modulus of rigidity, or we call it as shear modulus. Now what is the modulus of rigidity or shear modulus? It is the ratio of shear stress to the shear strain. Okay, now shear stress is generated by tau, or sometimes it is generated by Q also, and shear strain, that is phi. Okay, now then the bulk modulus, it is denoted by K. It is the ratio of volumetric stress or direct stress divided by or to the volumetric strain, sigma upon EV. We already know about what is EV. EV means what? Volumetric strain. It is equal to EX, EY, EZ. We have already seen in the last lecture. Now in the next section we will see what is the relation between the modulus of elasticity and modulus of rigidity, what is the relation between the modulus of elasticity and bulk modulus, and what is the relation between the three elastic constants, and depending upon that we will learn how to calculate the number of problems. Okay. Now before starting to the relation, we need to know first what is the lateral strain. We have already seen about the lateral strain means what? When a particular body is subjected to external applied force, what will happen? Now here the load is applied like in compressive nature. What will happen? The length of that body will decrease. At such time the transverse direction, at such time the another direction, that is this is the width and this is the depth of the body, it will increase by some amount. Similarly the depth of that body again also increase when the body is subjected to compressive force, and it is perpendicular to this applied force. Okay, now in such a case linear length will decrease. Okay, now here you can see it is less than L, and here width will be increase, depth will be again increase. Now again this strain is known as lateral strain. Now this is what? This is linear strain, and this is what? Lateral strain. Okay, and it is vice versa. If the linear strain is positive, okay, when it is positive, when we apply the tensile force on a particular body, and when we apply the force, nature of the force is compressive, the length will decrease, but the lateral dimension, that is depth and thickness, will increase. Okay, in another case, if the length in case of tension, length is increased, depth and thickness will decrease. Okay, got it? Now depending upon these terms, we have seen Poissons ratio. Now it is denoted by mu and 1 upon m. You can write any one, mu or is equal to 1 upon m. Sometimes it is given in the problem 1 upon m value. So don't get confused. Mu means 1 upon m. Now what is the definition of Poissons ratio? It is the ratio of lateral strain to the linear strain is known as Poissons ratio, and it is now here you can see minus. Why it is minus? Because it is vice versa. Okay, now if here you can see if EL is positive, capital EL, now small EL is equal to what? Linear strain, and capital L means what? Lateral strain. Now here if EL is positive, E capital L will be negative. That is, linear strain is positive, lateral strain is negative. If linear strain is negative, lateral strain is positive. Okay. Similarly, now in this case, minus lateral strain upon linear strain, then mu becomes minus EL upon small el. Okay. Now the formula becomes, lateral strain becomes minus mu into EL. Okay. Now we have already seen what is the value of mu, 0.25 to 0.5. Okay. Now the units of the modulus of elasticity is Newton per mm square. Similarly, shear modulus, Newton per mm square. For modulus of elasticity, again here stress and strain. Okay, then again here the unit for modulus of elasticity, Bablock modulus, is also Newton per mm square. Okay, now Poisson's ratio shows both are the strain, there is no unit, that is the unitless. Okay, but the value of Poisson's ratio lies between the 0.25 to 0.5. Some authors use 0.35, and it depends upon the metals. Okay, got it?